Okay, topic for this video is going to be arc length and sector area. Essential question is going to be, how are the lengths of arcs and the areas of sectors calculated? And let's dive in here. So first part, arc length. The length of an arc is the portion of the circumference of a circle. So it would be literally how long it is to travel from here to here. Right? We are not measuring in degrees. The measure of an arc is in degrees. The length of an arc is in, centimeters, inches, feet, something like that. So how do we do this? What is the formula for this thing? Well, it's all going to depend on the amount of degrees. So if our central angle is a certain amount of degrees, I'm using the Greek letter theta there to represent how many degrees it is, then the formula will be theta over 360 times 2 pi r. All right, so that theta represents how many degrees it is. The r is obviously the radius. And by doing that, we will find out the length of the arc. Now, you might recognize that 2 pi r there, right? 2 pi r is the formula for circumference. So what we're doing is we're essentially saying, hey, we don't want the whole circumference. We want a part of the circumference. And the part of the circumference that we want is represented by theta over 360, because the arc takes up a certain amount of degrees out of 360 degrees. So that's how we are going to calculate this thing. All right, let's give this formula a shot here. It says find the length of arc BD. Okay, so let's set up our formula. Times 2 pi r. So how many degrees does our arc take up? Well, it takes up 52 degrees, right? So we're going to do 52 over 360 times 2 times pi times the radius, which is 10. So I'm just going to punch that in my calculator, and we're going to see what we get. 52 out of 360 times 2 times pi times 10. I'm going to round it to the nearest tenth, and that is going to give me 9.1, and this would be centimeters. Remember, this is not degrees. It's 9.1 centimeters. We know that that arc would be 52 degrees. BEA this time. Arc BEA. Okay. So I know my formula is going to look like this. How many degrees does arc BEA take up? Let's find out. B to E to A goes that way. Okay, so how many degrees would that be? Well, a couple different ways we could find it. I mean, we know that from B to D is 120 degrees, and we should know that this whole side is 180 degrees. So if I do 120 plus 180, I get 300. So I'm going to do 300 over 360 times 2 times pi times 4. The 4, once again, is coming from the radius. So now that I've got that figured out, let me type that in. 300 over 360 times 2 times pi times 4 is giving me 20.9 centimeters. Okay. Now, what about BCA? BCA. Let me set up my formula again. All right, so BCA goes from B to C to A. So that's all this part. Now, how many degrees does that take up? Well, one way of thinking about it would be that the entire circle is 360. And the part that I want is the leftover part from the 134. So if I subtract that, 360 minus 134 would be 226. So this whole part's got to be 226 degrees. So let's put that on top. Oops, I wanted to highlight that. And then my radius is 8. So I'm going to put that in there. So let's do 226 over 360 times 2 times pi times 8. And I'm getting 31.6 centimeters. And there you have it, little arc length. Okay, so let's go to the inside and let's talk about some sector area. So sector area, the area of a sector is a portion of the area of the circle instead of the circumference this time. So a sector represents the actual area inside this piece, right? It's like it's a piece of pie, it's a piece of pizza. And the way that we calculate that is going to be, once again, doing theta over 360 to represent the amount of degrees that our sector takes up. But this time, instead of multiplying by 2 pi r, this time we're going to multiply by the area formula, which is pi r squared. And that will find us the actual area inside there. Because once again, that theta over 360 represents the amount of the circle that we want, and then the pi r squared represents the area of it. So very similar, only difference here is going to be that we do the pi r squared instead of the 2 pi r. So let's give it a shot. Degrees over 360 times pi r squared. If we want sector OAB, that's OAB, that's this sector. We can tell that the angle here is 65. And our radius is 2. So there's our formula. I'm going to type that in and we're going to see what we get. 65 over 360 times pi times 2 squared. I'm getting 2.3. And this would be centimeters squared because it's area. This next one wants us to find the area of sector OEDB. So that would be O to E to D to B. So that's this big sector, O to E to D to B, and then back. So we know our formula. How many degrees is that? Well, if we got that right angle in there, doesn't that mean that all of these are right angles, right? That's got to be a right angle. That's got to be a right angle. So that's 90 degrees. That's 90 degrees. That's 90 degrees. So that means 90 plus 90 plus 90 is 270. We got 270 degrees. And we've got a radius that is 8. Let's plug it in and see what happens here. 270 over 360 times pi times 8 squared. That's giving me 150.8 centimeters squared. For example, number 5. Next one says sector OACE. So let's follow those letters, see where it takes us. O to A, to C to E. Now if I go to the right, I would go E to C. So to go from C to E, I got to go this way. this way takes me to C and then to E. Now just as a quick rewind, because I know sometimes following the letters can be a little bit tricky. But if I go O to A to this way, if I go this way, I'm going to hit E and then C, and then I could go back to O, but I wouldn't be able to follow the letters in the right order, right? So the way to follow the letters in the right order would be O to A to C to E. Okay, so that's a very major sector there. That's over half of our circle. So I'm trying to fill out my equation here. How many degrees is that? Well, that would be the entire circle, which is 360 minus the 35 we don't want. That would give me 325. So that's how many degrees my sector takes up. My radius is 7. And now I've got everything that I need to plug this in. So 325 over 360 times pi times 7 squared. That is giving me 138.97. Oops, so we're just going to round this thing to 139. 139 centimeters squared. So it would round to 0.0, so we don't need to write that. All right, so hopefully you feel good about those two formulas. Those two are pretty straightforward. Let's get to one little tricky thing for this lesson. It's going to be talking about these things called segments of a circle. Now, a segment of a circle is a region bound by a chord and an arc. Now, you probably remember that a chord is a segment connecting 2 points on a circle. So it is bounded by the chord and the arc that it intercepts, that it cuts off there. So a segment of a circle is this part right there. All right, now, in order to find that, what we're going to do is we're going to find the area of a sector and subtract the area of the triangle. Now, what do I mean by that? Well, here's what I mean. So first, we will find the area of the sector, right? Like we just did, that whole thing. Then we are going to subtract the area of this triangle that we form with the radius and the chord. And that will find us the area of the segment. All right, so our strategy is going to be sector minus triangle. Okay, so let's give this a shot here. So find the area of the segment. So they want us to find, this part right here. Now to find that, first what we're going to do is find the area of the sector. Now the sector area formula is what we were just doing, where we do the amount of degrees over 360 times pi r squared. So how many degrees does it take up? 90. And what's our radius is 4. Now, just to be clear, what we're doing here is we're finding the area of this whole thing, sector OCD. Now let me type that in, see what we get. 90 over 360 times pi times 4 squared is giving me 12.6. Now let's find the area of the triangle. Now this is the triangle, right? How do we find the area of a triangle? 1/2 base times height. Thankfully, our triangle already has a right angle in it, right? It's got a base and a height. It's 4 and 4. So 1/2 times 4 times 4 gives me 8. So now all I got to do, 12.6 minus 8 to get 4.6 centimeters squared. Easy. Sector minus triangle. That's all we got to do. And that finds us the area of the segment. Let's try one more of these ones. It's going to be a little bit trickier this time. Okay, so this time we got this bad boy. They want us to find the area of the segment. Once again, the segment is this zone of the circle that's cut off by the chord. Step one of this process, find the area of the sector. Now the sector will be this whole big old piece of pizza, right? Formula for that, degrees over 360 times pi r squared. We know it takes up 120. We can see that our radius is 10. So let's start there. 120 over 360 times pi times 10 squared is giving me 104.7. Next, let's find the area of the triangle. Now here's where this one gets tricky, because the formula for the area of a triangle is 1/2 base times height. And the base and the height of a triangle need to form a right angle. We do not have a right angle in here. The last one, we got pretty lucky because it was a right triangle. So what I will do, I think the best option we can do, since this is an isosceles triangle, we should know that if I draw in the altitude of an isosceles triangle bisects the opposite side, and it bisects that angle, right? So instead of a 120, I could say that this angle right there is now 60 degrees. And since the altitude forms a right angle, I've got a 90-degree angle, I got a 60-degree angle. That means that this little guy, and this little guy for that matter, are 30-degree angles. I have created a 30, 60, 90 triangle. And if the hypotenuse is 10 of a 30, 60, 90 triangle, the short leg should be 10 divided by 2, which is 5. So the altitude of my triangle is now 5. The long leg of a 30, 60, 90 triangle is always the short leg times the square root of 3. 5 times root 3 is just 5 root 3. Which means that both of these pieces, since they are both long legs of 30, 60, 90 triangles, is 5 root 3. Which means that the entire thing here, the entire side of BD, the entire chord there, is 10 root 3. So the base and the height of my triangle, the two sides that make a right angle, would be 10 root 3 for the base and the height, which is 5. So 1/2 times 10 root 3 times 5, that would be 25 square root 3 if I get it as an exact answer. So to find the area now, I will do 104.7 minus 25 root 3. Well, since I already rounded the 104.7, I'm just going to round the whole thing here. 104.7 minus 25 square root 3. I'm getting 61.4 centimeters squared. Cool. All right, your turn to shine here. You got 2 arc length questions, you got 2 sector area questions, and you got 1 segment area question. It's a nice one though. It's not the 120 degree angle one this time. So give those a shot and then come back to see how you did. All right, hopefully that went well. For this first one, for a little arc length here, we should have been doing 52 over 360 times 2 times pi times 3. And let me see here what I get. 52 times 2 times pi times 3. I am getting 2.7 centimeters. For this next one, we want ADE. A to D to E. That should have been 270 degrees out of 360 times 2 times pi times 11. And type that one in. And I am getting, for that one, I'm getting 51.8 centimeters. Next up, sector OAB. That's just this one right here. Pretty nice one. We just got to do 110 over 360 times pi times 4 squared. Pi r squared for this one, of course, since we're doing sector area. 110 over 360 times pi 4 squared. I'm getting 15.4 centimeters squared. Sector O, BAC. O, BAC. Should have been going this way. 360 minus 38 is 330. Nope. 322. So we should be doing 322 over 360 times pi times 6 squared. And I'm and lastly, let's find the area of the sector first here. For the sector, we should be doing 90 over 360 times pi times 12 squared. That's giving me 113.1. And then 113.1 minus 2. For that, I am getting 41.1. And of course, that would be centimeters squared. So hopefully that went well for y'all, and that is going to conclude this video.